started at 6:05. So basically today we'll cover the week 12. Okay, once again, good evening, everyone. Am I
Good
audible?
evening, sir.
Yeah. Okay, so let me share my screen. My screen is visible, right? Hello.
Yes, sir.
Okay, so basically in week 12, there are two important lectures like 12.1 and 12.2. These are the two most important lectures. Others are kind of theory. So you can watch the lecture, and if you have any doubt, you can post the Discord, whatever you doubt. So like in NTAM also, like we'll be asking mostly in 12 point from 12.1 and 12.2. In the practice and graded assignment also, basically all the questions are from 12.1 and 12.2, right? Okay, so we'll first see 12.1. So basically we'll cover 12.1. 12.2 is basically relational algebra, and that query optimization and all the things is there. So I think relational algebra, like equivalent of relational algebra and all the things. So just watch the lecture, it will be sufficient for solving graded and practice assignment question, right? Okay, so okay, just fill the hurry, fill the that discrepancy form. We'll see all the
Okay,
things.
sir. I have filled actually. I have filled the form.
Okay, okay. Then we'll see your code, and if code is correct, then we'll give the marks.
Okay, sir. Thank you.
Yeah. Okay. So first we'll see the basic steps in query processing, right? So uh, so there are three process, like three steps. First is parsing and translation, then second one is optimization, and third one is evaluation, right? So what parsing and translation do? Parsing actually check the syntax and semantic tag of the query. So if you write any query, it will check that syntax, all the syntax is correct not. And semantic means like all the query whatever you select listed from table 1, table 2, table 1 is exist or not in the database, all the things checking by the parsing. And what translation do? It convert into the equivalent relation algebra expression, right? So parser and translator is clear for everyone.
Can you once again repeat for parsing, sir?
Parser means it will check the syntax and semantic check of semantic of the query, right? So syntax means like calculate as syntactically correct or not. Then semantic means like it determine whether the statements meanings, or example like see if you write select star from table 1, so table 1 exists in the database or not. all the things are checked by the parser. And translator what do? Translate is convert into the equivalent relational algebra expression. This is clear for everyone.
Yes, sir.
And for it may be more than one, for one query it may be more than one relational algebra expression, right? So what optimizer do? It will choose the among all equivalent plans, choose the one with the lowest cost. Like whatever the lowest cost, it will optimizer choose. Like how actually choose? Like it's statistic about the data, like it's like numbers of tuple in its relation, then like is any keys they are not, indexing is there not, all the things like see about the statistic about the data, and it will choose the most optimized, like yeah someone.
Sir, I want to ask one question here. So
Yeah,
you said that this translator will translate the query into relational algebra expression, right? And
yes,
then the optimizer will choose one of them. So does
yes,
it mean that it will translate into multiple relational algebra expression?
yeah, for one query it may be more than one relational algebra expression. We'll
Okay,
see with the help of one example, don't worry.
okay.
So maybe more than one relational algebra expression may be there. So it will choose like amongst all equivalent evolution plan, choose one with the lowest cost. Like it will see the numbers of block, how many blocks, numbers of six, all the things is like indexing is there not. It will choose the most optimized one, and it will give the execution plan, whatever the execution plan. So whatever the execution plan is there, it will give to the evaluation engine, and it will execute like whatever the tuple, and it will give the query output. So if you go to the, suppose let's go to the Postgres, that will be good. So let me share my screen, full screen. So entire screen. So my screen is visible, right?
Yeah.
Yes, sir.
Suppose if you write select start from students, this is university database, right? Uh, so you can see that now. Suppose how actually what is the execution plan? So in PostgreSQL, if you want to see, then you can explain. Then if you write in single, it will give that. Suppose if you want to know where name like uh, percentage a, something like that. So if you see, so first you can set file, first filter the name whatever the its content, like at end of the like a should be n, and sequential scan on the students. Suppose if you join any, suppose if you join like start from students, natural join text. So if you see, so you can see that what are the sequential and then has join, all the things, whatever the execution plan. If you want to see what actually execution plan for any query in Postgres, you can see that explain with the help of explain keyword what actually is doing, it will show. So execution plan is clear for everyone, and what evaluation engine do? So it takes the execution plan, and according to that, it will give the query output.
Sir, what is use of statistics about data?
Statistic about data means like numbers of tuple is there. So like various kind of metadata, you can see that.
Okay.
Yeah.
So, sir, can you repeat this again? Execution plan and evaluation engine.
So
As you
optimizer will give the whatever the most equivalent low cost, right? Low cost, right?
okay.
Now it will give the execute, like what will happen, like sequential scan, like which type of join it will be used. There are, we learn there are various type of join is there, then indexing is there or not. So whatever the how actually will proceed, that will give the execution plan, right?
Okay. So, you have taken example. What you are showing there, actually, I can't understand. Can you repeat that in the
Okay,
Postgres? Yes.
yeah. So, so you have written the query, right? Select star
Yes.
from natural join text, right? It will give the natural algebra between two table, right?
Yes,
There are
yes.
two table. So how actually perform, like we are getting the output, how actually getting the output, what are the, like behind the scene, like what are the backend before giving the output, what actually is happened, how actually, what are the execution is there. So if you put explain, then it will give the execution plan. So first sequential scan on student, then sequential scan on, then hash, then sequential on tax, then it will put the hash one. So like these things is like we did not learn, so it will like difficult. Suppose simple select star from students, I think that will be good. So you can say that sequential scan on student. So just scan on the student and print the output, kind of that. Suppose
Okay.
if, suppose where name, like where name, like a percentage, then first to,
Code, sir. Yeah.
so
No, sir.
yeah,
This is still wrong. Yeah.
so first filter the name, whatever the starting with a capital A, right? Then after that sequential students, kind of that.
Got it. Got it. Got it, sir.
Yeah. So whatever the execution plan, it will give to the evaluation engine, and it will, according to that, it will print the query output. Okay.
Uh, Actually, this is a this session is we are revision session, or it is week 12.
It is week 12. Revision session will start from next week.
Okay, because this kind of a diagram
Yeah.
regarding this query was I think in week 1 or 2
Yeah.
when we
Yeah.
start they were
Studying
showing.
week one.
Yeah. Week 1.
So week 12 also we are studying the same thing, is it?
Yeah. Yeah. It's something.
Okay.
Yeah.
Thank you.
And for revision session, I think we have, let me write. So we have planned 2 revision session. That will be Thursday, 1 revision session, and that will be Saturday, 1 revision session next week. So this will cover from week 1 to 8, and this will cover from week 9 to 12.
Sir.
Yeah.
Sir, one request. The Saturday class is clashing, sir.
Saturday class, how it's clashing?
Actually, sir, mentor session, it is clashing with mentor sessions.
Which mentor session?
Sir, I am a mentor for this term foundation, so it is clashing up. And I have pretty much doubts in week 9 to 12. So
I don't know, like you're in the mentor for which course?
Max 1.
Oh, maths 1. Okay, we'll see, like if any slots is available, then maybe we'll shift, otherwise we cannot do anything.
So can you shift
What
this
about this
to-
Saturday? This Saturday we're not doing any revision?
Yeah, this Saturday I will not do any revision.
Sir,
This
even
Saturday.
if even if you change the time, sir, please don't keep 11 to 1, because that is our bad one.
Okay. Yeah, I will see the slots. Like
Yes.
Sir, we can do it on Tuesday, sir.
okay, we'll see and we'll let you know.
Sir, please plan this session after 6 p.m.
Okay.
Okay, right.
Okay, so this Saturday session, like today will cover all the like important things in the week 12. So maybe this Saturday will cancel the session. Okay.
Let us not cancel. If you are taking, at least you can record it. Let us record it so that we can see it whenever we want. Let us not cancel, please, because see, these revision sessions are so important for us.
No, like this Saturday session I'm talking about, not
Okay.
next Saturday. This like
So, sir, instead of canceling the session, sir, keep it especially for the numericals like last time we conducted.
Maybe you can record it. Maybe I will not be able to attend if it is before 6 o'clock, but I will come and watch it.
okay.
Because sessions are there, it is good.
Okay.
Just
Yes,
just
sir. Please
first
don't cancel.
you can.
Yeah. So, Tarika, what type of numerical you want?
So
Sir, like last,
PYQ types.
yes,
Yeah.
sir, last time you took numericals just before quiz two, the all magnetic test.
Or
Three.
like important questions regarding the
Yes,
Yeah,
sir.
exam.
PYQ
All.
question.
PYQs you can do no previous year's questions.
Okay. Okay. Then maybe. See, this Saturday I have also
Suit
some
set.
other class. Maybe then, what we'll do, like maybe uh, tomorrow, or maybe like tomorrow evening is free. Then maybe I'll do some numerical on week 9 and 10, right?
Yes, sir. Tomorrow evening is fine, sir. Tomorrow evening is fine.
Tomorrow is
Okay. Okay, then I'm not like assurance. Like, I'm giving that I'll take the session. First, I'll see the what are the things are available. Then maybe we'll conduct one more numerical, like one session on numerical.
Sir, can you please tell me the weightage from week 9 to week 12 and week 1st to week 8 in the
Week 9 to 12 will be around 40 to 50%,
Okay.
and week A1 to 8, it will be around, I think, 50 to 60%.
Sir, when you take the numerical class, sir, can you please also consider those kind of questions where we have to perform a join and then we have to find how many tuples will be appear in that particular question, like minimum and maximum number of tuples.
Minimum on a maximum number of?
Sir, rows. Sir, in quiz one, sir, that kind of questions I have made mistakes.
Which I didn't know
Two
about it.
tables are given, and when we perform natural join, then how many tuples will be in the join table?
Okay, okay, okay.
Left
Maybe then.
router.
um,
And more, we requested this to TA as well as instructors also. 9 and 10, we are at least myself finding very difficult for attending those questions related to the serializability.
Okay, okay,
All the questions what they ask, it is mostly applied questions.
okay,
Those
okay,
questions, 9 and 10 specifically, I'm not able to solve any of the GA also.
okay. Then maybe like
Basically, 10
okay,
special class for the
okay, okay,
serializability, conflict, and the review. And then a lot of questions are there we are not able to solve. When you are solving, we are at least I'm finding it easy. But when I'm trying to solve myself, I'm finding it very difficult. And we ask more questions also, at least a question set
okay,
to.
okay. Okay, so maybe what we'll do, like maybe I'll take one more session. That will be like different types of numerical will be there. So like from week 10, that serial, conflict serializability, then numbers of view serializable, number of serial schedule, and all the things like
Locking or time, like
two-phase locking, and all the things will be there. So maybe I'll solve like from each concept, like I'll solve one or two question. I think that will be sufficient, right?
Yes, sir, but sir, try to like take those questions which can cover all the concepts.
Yeah, yeah. I'll take
Yes, sir.
like those question which will mainly important for NTM, and it will cover all the questions.
Yes, sir. Thank you.
Okay, so okay, let's give one example. Suppose you want to find that salary of instructors whose salaries is less than 75,000. So what will be the query? Select salary from instructor where salary less than 75,000. And what will be the relational algebra expression? One may be salary less than 75,000, salary instructor. One may be salary sigma salary less than 75 and instructor. So there are two equivalent relational algebra expression maybe, right? Correct. Now which one will be the most optimized relational algebra expression?
Sir, I guess the second one, because in that we are first filtering out the salaries which are less than 75,000 and then we are selecting.
Yeah, correct. Because here first we are filtering that whose salary is less than 75,000, then we are projecting the salary, right? So this will be the then what our optimizer do? Will choose the most equivalent relational algebra expression. Then it will give the execution plan, whatever the execution plan, and evaluation engine will take execution plan and gives the query output. Okay.
Sorry.
Huh?
Is any mathematical or any other calculations to know which relational algebra is more efficient?
So if you want to, like, you can also make a tree like structures. That 12.2, just watch the lectures 12.2. So you can see with the help of also tree also.
You mean to say that if I'm trying to for the given question, salary of instructor whose salary is less than 75,000, even
Okay.
I write in a non-efficient way, the database will, if it has previously efficient way of query, it will try to use that and fetch me the data.
Yes, you are only writing the query, right? But how actually, after writing the query, how actually give the query output, right? It's some backend things is doing, right? Some internal things is going on, right?
Okay.
Now first it will convert to the relational algebra expression, right? So like first you have to choose which one will be the optimized, right? Then after that we have to give the like which one will be the optimized. So maybe this one will be or this one will be. So here you can see that first we are giving that salary less than 75. First we are selecting like whatever that we are filtering the salary less than 75,000. After that we are projecting. So this will be the most optimized. Here you first projecting, then you are selecting like whatever that we are filtering. So this one will be the most optimized one, right? So first choose the most optimized. Then after that it will give to the whatever the that it will give the execution plan and it will give to the evaluation engine and give the query output, right? Now this statistic about that how actually optimize, choose which one will be the most optimized one, right? So that things will be not like how we measure the query cost, what will be like how actually like calculating the query cost. So there are many factors to like how like disk access time, then CPU time, then network communication, all the things like are measured. But for simplicity, we'll only see numbers of block transfers and numbers of seek transfers. So I think that in week 8, I think magnetic is like numbers of seek transfer and the like numbers of seek require and numbers of block transfer. So for simplicity, we'll see only two things: numbers of block transfer and numbers of seek. So for like TT equal time to transfer one block and TS for time for 1 seek. So cost for B block transfers and S6 will be B into TT plus S into TS. So if TT is the time to transfer one block and TS is time for 1 seek, then cost for B block transfer, this is the numbers of B block transfer, and plus S6 will be B into TT plus S into TS. For simplicity, we will be ignoring all the things. This is clear. Like what will be the query cost?
Sir, what is the seek? I forgot the seek. Number of seeks.
So seek means like suppose this is the magnetic disk, right? So let me finding the magnetic disk slide. Then after that will 1 second. I think it will be there. One minute. Desktop. It's visible, right?
Yes, sir.
Okay. So this is stored form of track, right?
Yes, sir.
Track. Sorry. So you can see that read write head is present in the this track, right? Right?
Yeah,
This
yes,
is,
sir.
suppose data is present in the this track. First we have to move the read write head into this track, right?
Yes, sir.
This is called seek time. Like
Okay.
yeah. Now clear, right?
Yes, sir. Yes, sir. Thank you, sir.
Okay.
So, sir, here TS is the seek time, right? Time
Yeah,
for
yes.
one seek.
Time for one seek, yeah, seek time.
So then what is S then?
S is numbers of seek required.
Number of seek. So
Required.
how we can calculate that?
So total will be like suppose B block transfer, number of block transfer. So B into for one block transfer required T time required, right? TT, right?
Yes.
So B into TT, right?
Yes, sir.
And suppose TS is the time for one seek and S is the numbers of seek required, then S into TS, right?
That I understand, sir, but we haven't find any question where we have to calculate the number of seek. I mean, I don't remember.
Yeah, we'll see like for each join how many times of seek required and how many times of block transfer required. Don't worry, like we'll see like there are various type of join is there. So in the nested loop, like how we'll calculate the seek and all the things. We'll see.
So that this formula we will use here somewhere in join.
Yeah, in join. Okay.
Sir, can you show this formula with those disk and then explain, sir?
Number of seek is not because we were thinking for a query, all the information will be available in the same block. So always we go one time and then
Maybe not
block.
present in the one block, right?
Oh, okay.
So it will it will require seek, right? If not present in the one block.
Present in the one block, then different. Okay.
Got it?
Can you once again explain on the disk, like where is one block and where is one seek, and with the formula, with this formula.
Okay, so this is called seek time. Suppose this is block. So mainly like that whatever that what we can say that smallest numbers of disks is called. This is called like whatever the what is called smallest sector, right? One sector.
Yes, sector.
So
Yes.
maybe it may be one block. Then after that one block maybe there. It may be one block there, kind of that.
Yeah, to block we are calling it sector, right?
Yeah, In one sector, maybe more than one block also present. In one sector, block means like one. It may be. Maybe you can say that a smallest units like one sector equal to one block. Maybe generally we do like that, but in one sector more than one block also present. But generally you tell that one sector equal to one block, right?
Yes, sir.
Okay. Okay, now we'll see selection operation or file indexation. So suppose you are doing the linear search. So what will be the cost? Suppose you are doing the linear search, and this some assumption is there. Here is like all the files are present in the one track. So suppose you are doing linear search. So what will be the cost if you are doing the linear search? First, one seek time require, right? Suppose, okay, let me explain. Suppose this is the kind of that. Suppose you want to find the one tuple, like this row is present in the node. So selection operation, right? So first you require one seek time, right? Then whatever the block transfer time. So if you want to find linear by linear, like sequence, like we can say that linear search, like first you go like one by one. So it will first will require one seek time, then plus numbers of blocks present in that. So numbers of block present in the BR into whatever the time required, right? So it will be time for one seek TS plus BR numbers of block present in the file, and TTL is the time to transfer one block. So it will be TS plus BR into TT. And if you if key is there, right? So we are taking average case. So TS equal to BR by 2 into TT, kind of that. It's clear for everyone?
So this BR by 2 into TT not clear. First A1 is clear. The first row is clear. Second
Suppose
row is
if
not able to.
key is there,
Key
so you
is
can
there.
find in the in first itself, right? Or you can find in the last also, right? So you are taking average case. So that's why BR by 2.
What key we are talking about? Which key?
It's maybe any key, like primary key or any key.
Okay.
Yeah.
Okay.
No.
You know what is
Yeah.
the okay.
Yeah.
In average. Okay. BR
Yeah.
by 2.
Okay. And suppose we are doing primary indexing, then it can be B plus T. So that's why HI plus 1, like height of the index, and TT plus TS. So all the things, like just to go through and try to understand all the things. Just solve one numerical, so that will be good.
Sir, we have to learn all these formulas.
For internal purpose, like I'll say, like this 3 will be sufficient. But I'll suggest like go through all the things and at least understand.
Can
Okay.
we go through here itself? We will just maybe with your help, it will be easy for us to understand. Because for BR by 2 is an average case.
Yeah.
What is the primary index EQ
If
on
there
key?
is a primary index on key, so indexing you have learned, right? Equation on key. Then we can use the B plus T, right?
Okay.
Correct. Then we can whatever the height. So first, if you want to find any record, then you have to height plus 1, whatever the height. Then T2 plus TS.
Okay. Here we don't need the BR, is it?
Yeah, because primary indexing is there. We will go that
Okay.
primary index. If you want to find one record or not, right? So that type
X
of
plus 1 will give us the number of levels, I suppose.
yeah, correct. That's why we can highest maybe H plus 1. So I'll go through like I'll say like try to understand all the things, like your thinking ability will be increased. So that's why I'm telling just what are the basic is required to understanding. I'm telling other things just go through. If you do not understand, then maybe ask in the chat or maybe discourse. I'll be ready to help. So let's solve this numerical. Then Let us consider the following statistics for searching condition within the given relation. Numbers of block containing record of the relation is 20. So numbers of block is 200, and time to transfer one block is 0.6 millisecond. Time for one seek is 8 millisecond. What will be the cost of selection query? Suppose you want to find some record using linear size file scan. So what will be the cost? Anyone?
8 millisecond plus 0.6 into 200.
Yeah, 0.6 into 200. So it will be 8 plus 6 into 200. Anyone?
12.
Uh,
120.
128, sir.
Yeah, so the millisecond. So it will be 128 millisecond. Suppose a selection query on key. So what will be that? Suppose you want to find the average case, then it will be
divided by 2.
Divided by 2.
Yeah, 8 plus 0.6 into 200 divided by 2. So it will be 8 plus 0.6 into 100. So it will be 68 millisecond.
Can we do the third one with the what is the third one? The A3. What will be for A3? Can we
Prime index
A2 primary index? Yes.
But then it will, you have to mention that height. What will the height? All the things. Then you have to mention other things also.
They will give the height. Okay.
That will give the height and all the things.
Okay, sir. Here we take the average case, or do we do worst case complex?
This is called average case. Average case on key. It will mention if it is the key, that will be mentioned in the question. Average case on key, and this is called linear search. So answer is for this question. Answer is this is. I am taking that if selection query on the key attribute, then what will be the answer? Okay. Now, so you know that you had various type of join, like natural join, inner join. Like how actually that join, that how actually internally happen, right? So there are different types of algorithm is there. So like nested loop join, block nested loop join, then indexed nested loop join, then merge join and hash join. So but our lecture will cover mostly like these two things, nested loop join and the block nested loop joins. How actually like internally happen, like we have blocks and we have a, so how, like how many seeks is required, how many block transfer is required, how actually, like which algorithm is used, right? So how this algorithm is work, right? So let's see. First is nested loop join, right? Okay, so suppose we want to do nested loop join, right? So how actually nested loop join work, right? So first order, what the tuple for each tuple tr. So tr is a r is a outer relation. So suppose we are doing student and text, we are joining student between and text. So suppose we are taking student as a outer relation. So what actually it will do? So first for each tuple, so for each tuple tr, we are doing for each tuple, then this is kind of like nested loop for each tuple ts. So first we are doing, then ts is a inner relation, text is a inner relation, right? Then we are testing each pair tr and ts. If it is matches, if it is satisfy the join condition, we'll add to the result, kind of that. So let's give the example, that will be good. So suppose this is a main memory, or you can say that buffer, right? And this is called hard disk or secondary disk, and this is containing that student table, and this is called outer relation, and this is called text table, and this is called inner relation, right? So first what we'll do, first we'll take this Raj 101, then we'll check with each tuple. First we'll check 101, it is matches, if it is whatever the join condition, if it is matches, it will add to the result. Then it will check with 104, if it is matches, it will add to the result. Then it will check with 106, it will, if it is matches, then it will add to the result. Then which this tuple, then it will this tuple, and this will add this tuple. If it is a message, it will add to the result. Then after that completion of Raj 101, what will do? This Ram 102. So it will check with this tuple. Then after that check with this tuple. After that check with this tuple, and this tuple, and this tuple. If it is a message, it will add to the result. After the completion of Ram, Rakesh 103 will compare with every tuple of inner relation. If it is a match, it will. After the completion of Rakesh, it will go to the sum. Like so, how nested loops and everything, like how actually works, it's clear for everyone.
Yes, sir.
Both these relations are in the buffer.
No, it's a hard disk. How actually works? Now I'll see what is the numbers of block transfer required. Now, how many seek required? Now we'll see. We'll see. Don't worry. Okay.
Here I have a question.
Yeah.
See, we are talking about two strategies, right? If you can go to the previous slide, there are two ways: nested loop, and there is one more.
Yeah, block nested loop then.
Okay, but what we learned so far is natural join, outer join, inner join. In join, you have right, left, all this different variants.
Yeah.
So nested loop join, we understand what you just told. Say, for example, if it is an outer left join, is there something it has to do, or it will just
it will work on the same thing.
I feel this is like a natural join.
Yeah,
it's
like correct. So whatever the join condition will be there, it will, if whatever the join condition, if it is matches, it will add to the result. It may be outer join, it may be inner join. What will be there?
Okay, that is okay. It has a condition inside the Okay, this will check for what is the join.
Yeah,
and
what
then
will it
as the inclusion in the final result.
Yeah, correct.
Okay.
Now, like how many block transfer require? How many seek require? We'll see, right? So let's see. So let's write in a clear way. That will be good. This is student table. This is outer relation. And this is text table. And we are considering worst case memory availability. What do you mean by worst case memory availability? Means like is only one block we can occupy in buffer or in main memory. Everyone got it? What is worst case memory availability?
Worst case, what are you saying, sir?
Worst case, like worst case.
The worst case.
Yeah. So worst case means like only one block of each, only one block of outer relation and only one block of inner relation we can like occupy in the main memory or buffer.
Sir, so this is worst means only one block from each, right? From
only
inner
one
and from
block.
outer. So if we will not talk about worst, then that means one complete relation can be stored in one main memory.
Yeah, correct.
Okay.
So so we are first considering worst case memory availability, right? So what will do? First it will go to the main memory, this block, right? So
Only Raj or the whole block, sir?
Whole block. This is whole block. This is called Raj. This is called Ram. And this is called Rakesh. This is called 101, 102, 103, and this is (101), C01, 104, C03, right? So only one block of each relation can occupy in the main memory, right? First, what I will do? First 101 will check with, and remember this all the blocks are stored in the continuous manner, like it will store in the continuous, right? So first it will check 101. Okay, so first me let's ask a question. So when it's moved to the hard disk to main memory, so how many block transfer is required? This one block transfer, what were this one block transfer, and here this one block transfer, right? Two block transfer, correct? Like, are you able to understand?
How?
So
Every
this,
tuple, are you calling it as a block?
yeah, no, this three
So
tuple,
these three
like,
tuples are forming a block, right?
yeah. So we are assuming like that three tuple are like storing in one block, max to three tuple, and here is like max two tuple can storing in the one block, right? So when we are moving to this block to the main memory, one block transfer is required,
Yes, sir.
and here one more block transfer is required. Two block transfer is required, right? Correct?
Okay.
This is block nested loop join, right?
No, this is nested loop join.
This is nested loop join. Okay,
Yeah,
and the one before?
that is nested loop. Like we are explaining that how actually nested loop join work. That what actually generally like how actually work now. Like now how this that nested loop
Block
join
transfer will happen.
block transfer and the seek transfer how actually happened, right? So
Here I have a question.
yeah.
For the left-hand side table, we have taken 3 tuples as a block. On
Yeah.
the right-hand side table, we have taken only 2. Why? Why cannot
It's
3?
it's
Because
nothing.
we say a block, right? But
Yeah,
here only, here
yeah,
3,
correct.
why here 2?
Yeah, correct. Let me explain. So
Thank you.
yeah, I'm intentionally do like 2 block because like idea and course it depend on the size of each tuple, right? It may be decrease, it may be like it may be less, it may be more, right? So it depends on the like size of each tuple. If size of each tuple is more, then in one block it will be less tuple, it will contain less tuple, right? If this size of tuple is more, then it will contain.
Yeah.
So that's why
Yes.
I'm taking 2 tuple.
Okay.
It may be same and may not be. It may be 2 tuple. That's why I'm giving.
So
Okay.
it can be 1 also. One block
It can be 1 also. It's depend on the size of each tuple.
Depends on the size of the tuples.
Yeah.
Okay. How many data it has. Okay.
Yeah. Correct. Okay. Now Raj 101, it will check with 101. If it is message, it will add to the result. Raj 104, it will check 104. This tuple, it will message if it will add to the result. After that completion of 104, this. Sorry. This tuple will move, right? This tuple will move to the main memory, right? Correct?
So, sir, how about the block which is already there, 101 and 104? So that will replace.
Yeah, that will replace.
Replace with the new block.
Yeah, replace with the new block.
Okay.
So it will.
Are we not going to do with RAM, sir?
No. That is a block nested loop join. We'll see. So it will replace with 106 C02 106 C02.
So
Now
the second tuple overrides the first one.
yeah. So when this block transfer, like another again block transfer required, right? When it's moved to the
Yes,
main
sir.
memory, it's another block transfer is required, and it's seek required or not?
No, sir, no seek.
Because the data is stored in the continuous memory, right? Continuous memory, right? So now what will happen? It will check with this tuple, this first tuple, and this first tuple. So after the completion of this block will move again. This block will move, right? Correct?
Yes, sir.
So this block will move. So this will be what will happen?
109 and C01.
108 and 1. Right. So after that completion of this, what will happen?
Then, sir, RAM will check.
Ram will check, and this block,
Again,
this
we'll
block
go to first block.
will go to the first block, right? Right. So again,
Sir, is there any cost involved while sending this leftmost block to the buffer?
cost in I did not got it.
Like we are moving this left block like ID and course ID to the buffer one by one. Is there any cost involved to move this block to buffer, sir?
Cost will be like you have to require time, right?
Yeah, time or
Time. What that's the cost. We want to minimize the time, right? If you write select start from something, so it will. If you which things you have prefer? That if you write something and it will print out like at the instant, and it will
yeah
at
taking
the
less.
instant. And suppose the sum, if you write select start from anything and it will take time, then it will print the result, right? So which one thing you will prefer? That instant, right?
Yeah, the one which take less time.
Yeah, that's okay. Now, so what will happen now? 102 with this again, this block will be moved, right? Correct. So 102 with 101, this block will be moved. C01, 104, C03. So 102 with 101, 104. After that, completion of this block will be moved, and after the completion of this block will move. So in that way, 103 will be also completed. So after that, what will happen? After the completion of 103 and 103 and this, what will happen? This block again will move.
So this time will it need seek time?
Yeah, this will require seek time also.
Okay.
And here also it will move. Here also seek time require, right? So in this way, like what we can say, this is block numbers of block transfer. Okay, now let's suppose. Okay, so now let's write the formula. So what will be the numbers of block transfer required? Okay, just 1 minute.
So inner join will also require the seek time.
Inner join, yeah, it will require seek time, right?
Okay.
It will require, right? So yeah. So numbers of block transfer. Suppose so let's see that. Suppose NR means number of block numbers of record in outer relation, and BR means number of record in number of blocks in outer relation. NS means number of
Calling here outer relation, sir, not
yeah
inner.
yeah no, outer. This is outer relation. Whatever that, this is outer relation. So number of record in inner relation.
And the left one, sir?
This is outer relation and this is inner relation.
Okay, sir. Thank you.
And BS means number of block in inner relation. So number of block transfer equal to what will be the number of block transfer? Anyone?
Sir, it's number of record in outer
NR
relation into
into
block
N
in outer inner relation, blocks in inner relation plus
Yes.
blocks in outer relation.
So this is the number of block transfer, right? Correct?
Yes.
Okay.
No, not able to understand this. Outer relation records into blocks.
This is called number of tuple in outer relation,
Okay.
and this is the number of block in inner relation. So you can see that for each tuple, it require block transfer for what are the numbers of tuple in the inner relation, right?
Okay. Records. Okay. Record is tuple. Okay. Into
Yeah.
blocks. Okay.
And plus you can also see that we have to each block you have to move into the main memory, right? So that's why BR. You got it?
It should be plus number of
Yeah, it
blocks.
should be plus.
Okay.
Okay.
Yeah.
So these things are not like clearly like not explained in the lecture. So these things are just properties and numbers of blocks. So how actually happens, I'm just explaining. And numbers of seek required will be NR plus BR.
But sir, in this seek time, we have taken seek only from the outer relation, but we discussed that the seek time will also be from the inner relation.
Okay, look, let me clarify that. So
Excuse me, sir.
yeah,
Sir, I recently joined the session and I don't know what's going on. Can you just briefly describe what's going on?
it's I think week 12 is going on, that that nested loop join is going on. So I'll suggest like watch the recording, or maybe that will be good, because we cannot explain like 5 to 10 minutes all the things.
Not all the things, just an overview that we are doing this thing.
So first we have seen that how actually query processing works. Then we are seeing that optimization, right? So I will actually calculate the optimization. So for simplicity, we are only using the numbers of block transfer and numbers of seek, right? Now we are seeing that how actually joins is actually work, right? So there are the different types of join, nested loop join, that different algorithm, right? Block nested loop join and next. So well, in the lectures mainly focus on the nested loop join and the block nested loop join. So now we are seeing that how actually nested loop join is work.
Okay.
Okay. Now we are seeing that 6, right? So
No. Yeah.
okay.
Okay. No.
So first, when we are moving to this, one seek is required, right?
Yes, sir.
Yes.
Okay. So that read write header will be at that position, right? Correct.
Yes, sir.
Now, then you have to move this block, right? Again, you have to require like one seek, right? Because read write had at this position. So again, we have to seek is required, right? Correct.
Yes.
Now, when it will move, it will not require any seek, right? Because just you have to rotate the disk. Correct.
Correct.
Now,
Provided it is in the same sector, right?
yeah, it will it will in the like it all the blocks are stored in the continuous memory, right? Continuous.
No. This one is what because when we first see the formula, there is a number of seeks into seek time, right? S into
NR
TS.
into BR. Numbers of seek required.
No. The previous, the first, I think the first page there was a formula, not this one. When you go to the first, I think first or second page, first or second slide.
Yeah.
Yeah, this one.
Yeah.
Here we have a.
You have mentioned that B
number
block
of seeks into TC time for one seek, right?
So see, you have mentioned that all the things we have mentioned. So how many block transfer is there and how many 6 is there and what is the time for transfer one block and what is the time for 1 6. Then we are
Okay.
calculating the cost. What will be the cost?
Just this is just okay.
Yeah,
It is
general
not
is
specific. This one.
yeah.
Okay.
What is the numbers of what number of block transfer is there?
Given
Yeah,
a block time
yeah,
for transfer, given a
yeah,
number of
yeah, correct.
okay. This
Now,
is
So earlier we computed B, right?
yeah, numbers of what is the numbers of block transfer?
That was
Yeah,
our
this is
B.
yeah, this is B. Okay, right? Now, okay. Now 106, 108. Now when uh, RAM 102, so 101 and 108 when it's completed, then you have to move this block, right? After the completion of 108, 108, right? Correct? Hello, I think
Yes.
Sarika,
yes, yes, yes,
Yes,
yes.
sir.
We are there. We are
then
there.
when it will move to the this, again one seek required because we cannot move in the reverse direction. We can only move in the one direction, right?
Yes, sir.
That's why again one in seek required. When
When we
103,
move from Raj to Ram, we need another seek.
yeah. Then when will require Rakesh and 108, then we have to move this block. Then
So, sir, when we move Raj to Ram, that represent NR, right?
yeah, that
But
is
when we
NR.
change the block, like we traverse everything from the inner relationship, then we change the block, outer
Yeah,
block. That represent BR.
yeah, correct.
That is the seek time for BR,
Yeah,
right? That is
correct.
BR. Okay.
Yeah, correct. So now when 103 and 108 completed, so read write had only be that position. So we have to move this block, right? So again one seek required. Then read write had only be that these things. Again one seek is required, right? So that's why NR plus PR. I think there is a one discourse post also there. So if you did not understand, I'll share that discourse post. That will be good. This is clear for everyone? Hello.
Yes, sir.
No,
Okay.
it isn't.
Okay. What is your what is your
I
doubt?
understand why it is NR because for every record we have to seek back to the
Yeah,
outer
for every record
outer.
we require a
We have
seek.
to go to the outer record, right?
Yeah, correct.
But
And
why BR?
for every block, we are again another seek required, right? For every block, this outer relation.
Okay.
Because we are changing the block now.
But is
Yeah.
this the total seeks? What about the seek for the inner relation?
Yeah, this is total seek NR plus PR.
No, we don't need a seek for the inner relation. You were saying we have to move the head to
That is the
104.
yeah. That's why when we are changing, so again one seek required. Right? We are calculating, right? For we are when changing RAM to RAM one seek, and when block is like another block, we are again one seek. That's why NR total numbers of record and total numbers of block present in the outer relation.
Okay, so you're saying the read write head first has to move this block, outer block up, so that is one seek. And then for every record, the read write head has to seek all these blocks once for.
At that time, one more seek required. Did you got it? Or like if you have doubt, then maybe.
It is, see, when we seek when we go to that record for the outer record,
Yeah.
We take when we seek to Raj and then take it to the main memory, we take the entire block Raj, Ram, and Raj.
Yes.
So that then why NR? Why number of records? It should be NR by.
Okay. Okay. Let me explain. So when it is moved. Okay. Let me. Yeah. I'm got it. What you saying? Okay. 1 minute. Just. This is Raj. This is Ram. This is Rakesh. 101, 102, 103. So this time one seek required and
Yeah,
one
all
zero,
three. Yes.
yeah, two seek required, right? 104 and 101.
This is one seek. Yes.
Now when completed 101 to 104, so that time this block you have to move, right?
Yeah, it has to be another seek. Yes.
It does not require seek because it
Yeah, no seek, only moving only required.
yeah.
Yes.
When completing 108, 101 to 108 last record,
Yes.
so then you have to move that block, right? Correct?
Yes.
So that
Yes.
time we can move only one direction. So that time one more seek required. That's why when we are changing to another record, again more seek required, right?
No, we cannot rotate it because if we rotate, it can come to the same point. No,
But
it
it
will not.
cannot do the reverse direction, right?
No, on the same direction. If it rotates, because 360 it can rotate, right? When
Yeah,
it
yeah.
rotates to 360, it has to come to the same point without seek.
That time,
Because this is where I got confused when we are saying. And here, for me, I feel like NR by 3 will be better because NR by block size, NR by BR. Because number of block, it's not even number of block size. Maybe that will be the number of seeks required for the left hand side.
okay.
Because
So
I will be taking only that many number of time because every block I take 3 records.
yeah.
So number of records by 3 will be the number of seeks for the left hand side. For the right hand side, it will be every time, right? So that also defined by this. That also defined by the left hand side only.
Okay, so
This going this many records.
okay, so yeah, but that time it's like you can more secure because
Sir,
yeah.
what I understood is like for inner relation, it goes sequentially, right? And for blocks, like we are storing in the main memory block wise.
Yeah, correct.
So that's why every time when the block change, then
Yeah.
we need a seek time.
Yeah, correct. We need a seek time.
Yes, but when it goes sequentially,
Yeah.
We need once. It just one seek
Yeah.
time we need.
Yeah, correct.
That's why it is NR plus BR.
Yeah, that is
my understanding.
Correct.
R plus BR.
Yeah.
Number of blocks.
Yeah.
Okay. The number of records.
Okay, so let's solve one more numerical. That will be good. Consider the information given on relation project and relation allotment in table 1. Answer question. So ignore that. Answer question 11. So project is relation project allotment. Numbers of record 2000 and for allotment is 9000 and numbers of block is 2000 and 6000. Consider the worst case memory availability. Assuming allotment as outer relation, identify the correct cost estimate for the nested loop joints, allotment and project. So we are allotment as outer relation. So we are considering allotment as outer relation and project is the inner relation. So what is the numbers of block transfer required? So and you have to find the numbers of seek required. So maybe I'll wait 1 minute. Maybe we can solve.
Sir, like in this we can like directly do the seek because it is easy to calculate and then we can find.
Yeah, you can do whatever you want. So I'm writing numbers of block transfer will be NR into BS plus BR, where BS is number of I'm not writing.
Done.
Outer relation. Her BS is number of block in outer relation.
Sir, inner relation, na?
Oh, sorry.
Number of blocks in inner.
Yeah, correct. Thanks. Inner relation. And BR is number of block in outer relation. So, Henian, what is the NR? Allotment is the outer relation. What is the NR?
9,000.
9,000.
90,000. And what is the BS?
200.
200.
And what is the BR?
600.
9000 plus 600. It will be 9600. Oh, we have to. Okay, so.
So 180,000
just
plus
done
600.
Yeah, sorry. So it will be.
180, 600.
Yeah,
1800600.
1800 600 block transfer. Numbers of seek require equal to
9,000 plus 600.
So it will be 9600 seek require, right? Let's solve another problem.
Can you go to the page, sir? 1 second, please.
So CK is equal to 90600.
Yeah.
9600.
Yeah, correct.
Sir, here seek, we have for number of block. Why we are taking 600? It should be 200. Number of
Seek
block.
is NR plus BR. Number of block in outer relation. And number of record in outer relation and number of block in outer relation. So 600, right?
Okay, both we have to take outer only.
Yeah, both you have to take outer one.
Done, sir.
Okay, and solve this problem. Similar question. I think this is a assignment as a outer relation. What will be the answer?
The B option.
B, sir.
Second option.
Block into NR into BS plus BR. So what is the numbers of record in outer relation?
So 5,000.
5,000 into number of block in
100
inner
plus
plus.
300.
So it will be 500
500,000 plus 300.
blocks. And seek require
5,000 plus 300. 5,300.
NR plus BR.
What is PS here, sir?
Numbers of block in inner relation.
Okay, sir.
So job is the inner relation, so 100, right? Okay. Now we'll see the we have learned about the nested loop, right? We'll learn
This
about
is just the number of blocks and the number of seeks, right? But
Yeah.
we haven't calculated the cost here.
So cost, what will be the cost?
The above number into TR.
Yeah. What is the suppose numbers of like for one transfer block its time is let's go to the formula. So TT is the time to transfer one block and TS time for 1 6. So what will be the cost? So what will be the block is there? You have to multiply with time to transfer one block. In order the seek require, you have to multiply with time for one seek.
Yes.
And sir, if the job is outer, then 3000 into 300 plus 100.
Yeah, then you have to calculate the. Okay. Now I'm forgetting that we have to learn about that. Block nested loop join, right? So block nested loop join, how work? So let's go to the block nested loop join. So how actually this block nested loop join work? So first what we'll do, Raj 101, first it will check with this tuple, first tuple. If it is matches, it will add to the result. Then Raj 101, it will check with 104. If it is matches, it will add to the result. After that, what happen? This RAM 102, will check with 101. If it is matches, it will add to the result. RAM 104, check with 104. If it is matches, it will add to the result. Then after that, 103 will check with 101 and 104. After the completion of this, what will happen? It will check with this tuple, right? So let's suppose this is the main memory and this is the hard disk. So we are considering worst case memory ability, and this is the student outer relation, student table, and this is the text table inner relation, right? So what will happen? First, this like worst case memory ability, like each block, like only one block can contain in the main memory, right? So suppose this is the Raj, this is the Ram, and this is the Rakesh. 101, 102, 103, and suppose this is 101, C01, 104, C03, right? So first what will happen? This tuple Raj 101 will be checked with this tuple. Then after this tuple, if it is message, it will add to the result. After the completion of this, RAM 102 will check with 101. If it is message, it will add to the result. RAM 102 will check with this tuple. If it is message, it will add to the result. After that, what will happen? 103 with 101. If it is message, it will add to the result. 103 message 104. If it is message, it will add to the result. After that, what will happen? This block will add to the result, right? Please mute, otherwise I have to mute. So after that, what will happen? This block will move. This block will move 106, C02, 106, C04. So first we'll check with this. If it is message, it will add to the result. Then after that message with 106, it is message, it will add to the result. Kind of this like this is the way like in a block nested loop join work.
Sir, what
Have you got it? Yeah.
So we are saying if 101 matches, what we are matching here, sir?
So let's (101) C01, right? 104 C03. So it is message whatever the condition, whatever you have given condition, what if satisfy, then if it is satisfied, then it will add to the result.
Okay.
Yeah. Okay. So what is the numbers of block transfer required here?
BR into BS plus BR.
Only blocks.
Yeah, correct.
Number of blocks on this.
Number of block transfer is required equal to BR
B
in
plus
BS
BS
plus
plus
BR.
BR.
And number of seek required equal to 2BR. So if you like if you compare, so in the nested loop NR into BS plus BR, right? Each block, so that's why it will BR and NR plus BR. So we are checking only the numbers of block in. So this is also BR, so it equal to 2 BR. So if it's combined, so this is like first, right? Okay, so let's solve another numerical.
But the number of blocks, why it is BR into BS plus BR is coming?
Okay.
It is not BR plus BS because only once we are shifting both, right?
Okay.
We
Okay.
take the left hand side record.
Okay.
And
Let
then
me
take the right hand side record.
Okay. Okay.
We match everything.
Okay. Let me first. It will move to the this, right? For each block. Raj, Ram, Rakesh, 101. For each block, that BR into BS, you got it, right? Right?
BR into
BS, you got it, right? Right?
This many blocks I am shifting.
This
Yes.
up to this is you got it, right?
Yeah. Yes.
So after the completion of suppose 109, C01, 108, C01. After the completion of this is 103. After the completion of this, we have to move this block, right?
Yes.
So that's why
BR.
That's why BR plus BR. You got it now?
No, that
for
is
each block.
there in the BR into BS, right?
So for each
BR,
block, for each block.
Okay.
For each block with BR into BS, but after the completion of one block, again this block will be moved right into the main memory. So at that time also block transfer required, right?
Okay.
Right.
Plus BR.
So yeah. So
Sir,
like yeah.
Because for me, I'm moving only once. The BR, see, Raj, Ram, Rakesh moved only once.
Yeah, only once.
Sham,
So that
Ajit, Rudra is also moved only once.
Yeah, correct.
So that is BR.
Yeah, that is BR. You are moving the numbers of block. So you are moving it. That time also block transfer required, right?
Yes, but why I'm only once that is already there counted into BR into BS, right?
No, that is not counted. That is after blocking move, how many block transfer is required? Then what are the numbers of block in the inner relation?
Yeah,
that is BR into BS.
Okay, BR into BS. I'm moving this and then checking all the things.
Yes. Then after that again this block have to move, right? So again this many like again that BR required.
Okay. Let me maybe I need more time. Okay, no problem. Please.
Okay, so let's solve one more numerical.
Second that you have written.
Yeah.
The formula you wrote just now.
Yeah.
Sir.
Okay.
Let Ravi complete, then I will ask. He wants to ask something.
BR.
Okay. Can you repeat? I did not got it.
You have written BR into BS plus BR, right?
Correct.
So why we are taking these many things? For previous, we did compute in different. What we call this?
This is called block nested loop join. How block nested loop join work? Previous one is the nested loop join. This we are doing block by block.
Block nested.
This is block nested loop join and initial level nested loop join. So there are two types of join: nested loop join and the block nested loop join. So initially previous it was the nested loop join. Now block nested loop join.
So in nested loop join it is NR into BS plus BR, right?
No. For nested loop join it is NR into BS plus BR. For nested loop join.
Yeah, for nested loop join.
Yeah.
And for
block nested loop join, BR into BS plus BR.
Okay, sir. Got it. Thank you so much, sir.
Yeah. And Tarika, yes.
Sir, I wanted to ask, like, only the worst case scenario is in the syllabus, or do we have like, what if all the blocks are stored in the memory? Like.
Okay, then best case will be BR plus BS.
BR plus BS. Okay.
Yes.
So for
Best
both,
case.
right? For both
For
nested as well as for block. It is same, right? BR plus BS.
yeah, for both BR plus BS.
For the seek, instead of 2 BR, it should be BR plus BS.
Only
right?
two. It is only two seek require, right? Because all the things will be stored in the main memory, right? Then no seek require, right? Okay, let me explain the best case.
No, seek no, not the best case. I'm talking about the worst case.
2 BR.
That's what. How it should be BR plus BS. No, it's not like that.
No.
Because one time I'm seeking number of blocks.
So
BR.
see, okay, let me say, see, for when you are moving to this one seek require, right?
Yes.
That
So-
time one seek required, and
Yes.
when you are moving, then you are also moving to that, right? That time one seek
Yes.
required.
Yes.
All the things are continuous. Then again we are moving to this block. That time again one more seeker, okay? So when we are moving BRs, that time requires seek, right? Other type does not require seek. That's why 2 BR.
Okay.
Yeah. Okay. So
you are telling the seek time for the best case.
Oh,
You said that two, it will be two. So two
okay,
for
okay. Let
both.
me, yeah, two for both. Let me explain the best case. So, what will be the best case? Best case will be.
So these both were worst case?
Yeah, both are worst case. Like best case is pretty simple. Best case means like all the memories, like we can whatever this we can store in the main memory, right? So
Yes.
that time one seek require, and here it's one seek require, right?
Only 2 seeks.
Only two seek require.
So, sir, like if the full outer relation, it will store in the main memory.
Yeah.
And then for inner relation, so will it go blockwise? Like it will go blockwise,
No,
right?
no. It will like if all the
No, because
Uh,
if memory doesn't have space, it can store just one full relation. So it will
yeah,
store
then
the outer relation.
yeah, then you have to see like then there are different cases. Then how to do all the things, and it will go the blockwise.
No, because so best case is you are saying in the main memory we are storing both the relation, complete
Yes.
relation.
Yeah. Then it will be best case, right?
And block transfers will be BR plus BS?
Yes. Yeah, BR plus BS.
Okay.
Okay. Okay, let's solve that numerical then. Block nested loop then. So what it will be BR into BS plus BR.
Last.
The last.
Sir.
Okay, so what is the BR? Number of block in
600.
allotment is the outer relation. So 600 into
200.
600 into 200, right?
Yes.
200
Plus
plus
600.
it will be 120600 block transfer, and numbers of 6 will be
Twice BR.
twice into BR. It will be 2 into 600. Okay, that's last one. And let's up this also.
So last option.
Yeah, again, so it will be numbers of so assuming assignment is the outer relation, right? So numbers of block. So BR into BS plus BR, numbers of block in outer relation 300, right? 300. Numbers of block in inner relation, it is 100, and numbers of, so it will be 303. All are the like PYQ, like all are, this is previous year random question. And what will be the number of 6? 2 into BR, 2 into 600. So it will be,
Sir, actually these options are easy to guess because of BR, twice BR we can check and we don't need to calculate actually.
yeah. So
The block.
okay, so 600. Yeah, maybe we'll lux then calamity.
Yes, sir.
Okay. Okay, so this is all about week 12, and week 12.1, 12.2 is the, I think, relational algebra, equivalent relational algebra expression. So that's things, just watch the professor lectures, that will be sufficient. And we can
Which
attempt
one?
all.
Which ones?
12.2. In
12.2 we watched the professor's lectures.
yeah. So like in week 12 there are only 2 lectures are important, 12.1 and 12.2. So basically other things are like theoretical, so we'll not ask any end-term question from 12.3, 12.4 and 12.5. So mainly these are the 2 important module, so you can focus on the 2 important module.
Sir, which week is important as per the theory? Like theory questions, because ma'am said 85% questions will be numerical, so 15% will be theory. So
I think whatever we cover in the live session, that is sufficient.
sufficient, right?
Whatever the and like we'll be asking only conceptual question, don't worry, like about if you have concept is clear, then we can solve it.
Okay, sir.
Yeah. Okay, then any doubt? Otherwise we can bind up the session.
So please schedule one more class for week 9 and 10 numericals.
Okay.
Yeah.
We'll try to schedule one more session.
Yes, sir.
In this week, sir, if possible.
Yes, sir.
In
If it is early, it is better so that we will know what we don't know, and then we can ask more doubts. Then, if it is at the end, at the end of very near to the exam, then it's very difficult.
Okay. Maybe
Early is
Sunday.
better.
Okay, we'll see, and we'll.
Yeah, it would be preferable if this weekend we have a revision session.
Okay. We'll try.
And could you please share this particular slides on the supplementary comment?
Okay, we'll share. Okay.
Sir, share the annotated slides, sir.
Okay, but I remove all like maximum things, because if you saw, I'm like, if you want, I can give, but
This lecture is not recorded, sir.
This lecture is recorded.
No, sir.
Yeah. So maybe I'll share the slide, because if you see the annotation, you cannot understand all the things.
Sir, we can understand who attended the session, sir.
Okay, then I'll share that. Okay, then good night, everyone.
Good night, sir. Thank you very much.
Thank you.
Thank you, sir.
Okay.
Thank you, sir.